Bismillahirrahmanirrahim. As I promised in my previous video that we'll use another method to solve this practice problem 8.10. The initial descriptions etc. are same. This is the question. We have to find V0t, the voltage here for t greater than 0. And the note here is given is that you have to find V1 and V2. So these are the steps that we follow. And I hope you can read them and pause and understand what are these steps. The first step is that we find t less than 0. At t less than 0, find the value of current and voltage. In this case, there are two voltages, V1 and V2, so we'll find their values. But before we proceed, let's understand this. 20 ut means 20 is multiplied by ut, and ut is 1 after 0. Before 0, it is 0. So 20 ut will become 20 multiplied by 0 equal to 0 for t less than 0. That means our circuit will become like this. The source is short-circuited, eliminated, 0. And from here now you can see that there is no source to charge the capacitor. Therefore, voltage V1 and V2 will be 0 in this case. So we can write that V1 0 minus is equal to 0 and V2 0 minus is also equal. So this is our first step. The second step is we find V1 0 plus. Immediately after the situation changes, and that means our now this will be 20 because ut is 1 now for t greater than 0. So this will be the circuit. And now a very important property that we'll be using, property of capacitor, is that the capacitor voltage cannot change instantaneously. Although we had applied this source, but the capacitor voltage was 0 initially, it will remain 0. V1 0 plus is equal to V1 0 minus equal to 0. And similarly, V2 0 plus is also equal to V2 0 minus 0. Now the third step, we'll find dV1 and dV2. Now these values we'll be using subsequently. To find that, we'll use the KCL equation from here. Node 1, so we have current I C1 and this current which is V1 minus V2. And now we put the value I is V1 minus 20 divided by the resistance. IC1 is the capacitor current, T dV dt, 1 over 2 is T, 1 over 2 dV1 T dt, and this one is V1 minus V2. Now we'll eliminate 1 from the denominator. The equation will be this. Rearranging, this is our equation number 1 in terms of a derivative. And now we can find out the value of dV1 0 plus by putting t is equal to 0. So at t is equal to 0, this will be dV1 0 plus, this one also 0 plus 20. We know the value of V1 0 plus and V2 0 plus, well 0 0. So our equation will be half dV1 0 plus is equal to 20. From here, we take to the right hand side, so it will be dV1 0 plus dt. So we keep it for later use. And now we have to find dV2, so we'll use the KCL at node 2 here. This current V1 minus V2 1 is equal to IC2, which is 1 over 3 dV dt. So it is 1 over 3 dv2 dt. And here also we'll put t is equal to 0. V1 0, this is also 0 plus, this one also 0 plus. But these two we know as 0, value is 0, 0 minus 0, 1 3 dv2 dt is 0 plus, and that means dv2 dt 0 plus is equal to 0 volt per second. And so we also keep this for later use. Now these are the four things that we have found. These two equations we found for the source on, and these two values that we'll be using later on. Now we obtain the characteristics equation, and for characteristics equation we are supposed to turn off the source, because actually we need to find the natural response. So turn off the source, and here also we'll write KCL at node 1, KCL I1, I2, I3, 0. Putting the values now, this case, remember I1 is only V1 divided by 1. Here it was earlier, it found V1 minus 20 divided by 1. But in this case, when the source is short-circuited, it will be V1 divided by 1. And these two remain same. Solving. So this is rearranging our equation number 3 for the characteristic equation. We need another equation. We have V2. Applying KCL at node 2. I3 is equal to I4. I3 is V1 minus V2 over 1. This is 1 3 dv dt. So we had found equation number 3, and this is equation number 4. We'll be using these two to form a differential equation. What we'll do, we want to get equation in terms of V2. Now, in the first method, we were getting equation in terms of V1. Now, I'm just showing it that if you want to get the equation in terms of V2, equally good, no problem. So for V2, method 1, we had solved it for V1. So for V2 will be from equation number 4. We'll use V1 equal to this, and we'll put V1 into the other equation to get V2. So from equation 3, we'll put the value of, this is equation number 3, and from here we rearrange. V2 is 2VA and half dVA, equation number 6. Now we plug in the value, putting in the value of V1 from equation 5, this value V1 in this equation, everything in terms of V2, solving, multiplying by 6 to make it simpler. So this is our second degree differential equation. And now to simplify this, we just write S d over dt is written as S square here, S square V2, and this is 7V2, 7SV2, and 6V2. Take V2 common, multiply by 0 to the right hand side. So this is the characteristic equation. And factorize to get the two factors. S1 is equal to -1, S2 is -6. So these are the two roots of the equation. And now the natural equation, the solution is given by this formula. C e raised to the power S is a -1t plus d e raised to the power S2t. So this is the natural equation. Now the complete solution is given by the steady state value and the natural value. To find the natural value, we need to find the steady state value. And the steady state value means that the circuit has, or the capacitors have been fully charged. And so the voltage V1 or V2, they are fully charged to 20 volt. And therefore, VSS is 20 volt and then V natural. So this is our equation in terms of V2. Now we need to find C and D. These were the values. This is the equation. How to find C and D? Easiest point is that we put T is equal to 0 here. So this would be V2 0 plus equals 20. E raised to the power 0 is 1. E raised to the power 0 is 1. And V2 0 from here is 0. So putting this, we get equation number 9. If there are two variables, therefore we need another equation. For that, we differentiate equation number 8 with respect to T. Differentiating with respect to T, we get this constant 0, this minus T e raised to the power minus T and minus 6 T e raised to the power. Here also we put T is equal to 0. If T is equal to 0, this will be 0. It will be minus T because e raised to the power 0 is 1. And here it will be minus 6T or e raised to the power minus 6T. 0 is also. So now dv to dt, we have already found it to be 0. We plug in that value. Rearranging, we get the value of C to be minus 6D. Now we put this value into equation 9 and we get the value of E to be 4 and C to be 24. And so our V2 equation with all values done, 20 minus 24 e minus t plus 4 e raised to the power t. So V2 we have, now we need to find V1. So we'll use this equation, the original equation, to find V1. From equation 2, we get V1 is equal to V2 plus 1 over 3 dV2 dt. We know V2, so we'll plug in the values. Plugging in the value of V2 here, solving, and final value is this one, 20 minus 1680 minus 4 minus 6. V1 and V2 we both found. We can find V0 now, which is V1 minus V2, V1 minus V2, and solving we get it 8 e minus t minus 8 e minus 6t. Taking common, this is the value, is the answer, and it is the same answer that we got in method 1. I hope you have been able to follow this. Please let me know through your comments. Thank you.